Hey, what's going on, folks? It's Mike here, and welcome back to my Deep Programming Language series. In today's episode, we're going to be looking at the package visibility attribute. So if you're coming from the C++ language, let's say, you'll be very familiar with private, protected, and public visibility attributes, but package is going to be something that's likely new for you, unless you've used some extension or maybe some other weird system. But anyways, let's go ahead to dlang.org and check out what exactly package is. And we're going to go to the documentation section, the language reference, and I'm going to jump down to attributes here. So let's go ahead and check this out here, and you'll see the visibility attributes here. So I'm going to briefly recap this, and we're going to spend a little bit of time setting up a project so that we can actually see how the package attribute is useful. So I'll try to provide a sort of real world use case where we might want to use this, but let's again review the visibility attributes. So the first thing that I'll say is we're not going to yet talk about export. We'll do that in a future video at some point, so make sure you stay tuned for that. But again, we have basically 5 attributes here. Now you'll notice package is listed twice. I'm going to give you a basic use case, but you can add some additional qualifiers if you need a little bit more nuance here. So let's go ahead and before we get to package, talk about these 3 here: private, protected, and public. So going in sort of reverse order here, public is the default in the D language. So whether you have a class, a struct, functions, or these types of things here, that means that, well, you can basically just see stuff. Okay, so that's the first thing to keep in mind. So that's public attribute. Private in the D language is basically this idea that you can reduce the visibility of your symbols to just that module. Now, again, this is going to be a little bit weird for folks coming from maybe other object-oriented languages or other languages where you have visibility attributes, that private means within the same module. So if I have a struct and I have a private member variable, I could still see that in other functions that are within that same D file, because again, a module is the default encapsulation unit. So again, that might be something a little bit new to folks here. I personally sort of like it, and there's an easy fix of just put everything in its own file if you don't want stuff to otherwise see other things. But again, package will come in handy here for that very reason, especially if you don't like this default here. But again, I think it's sort of the right pragmatic thing to do. But anyways, that's public and that's private, and it sort of works the same for classes and structs as you might have used in other languages. Now, protected, again, only applies to classes because this has to do with inheritance. So you can read the description here for basically when you're deriving a new class. Okay, so just a little review there on private, protected, and public, which you're probably used to. But let's go ahead and talk about package. So the basic idea with package is that it extends private. It's saying, hey, I've got this thing that's, we want to encapsulate within a module, but if I have a package, which is a collection of modules that I've separated out, I don't want to pay for that sort of penalty of hiding things. I wanted to, separate out my code into separate modules for, maintainability purposes or whatever reason. Now I still have visibility, and I don't have to sort of upgrade more and make it public or exposed, but I can still manipulate or change or have access to that variable. In some ways, it's kind of similar to the idea of a friend sort of thing in C++, but it still restricts it to a, just within that package. So it's a really nice thing. It's a nice tool. And I'll try to give you a pragmatic use case here. All right, so with that introduction, I think it'll be useful if we just see some code and sort of set up a little project here. So what I'm going to do here is just kind of set up the tree hierarchy so you can get a little bit of a review here on how to set this up here. And the basic idea is let's set up a little hierarchy here. So I'm going to go ahead and create a folder here. I think a good example here is if you're making a game where you're creating some like object type. I mean, maybe you have something more generic, but let's just do like ogres or something, or like some bad, goblins or ogres or something like that here. So anyways, let's go ahead and take a look at that example. So I've got a directory here, and what we go ahead and do here is make a few files here within the ogres directory. So I'm gonna have my package .d where everything will be. Let's put in also the ogre.d, which is gonna have sort of our base struct in it, or class if you choose. And then let's go ahead and do another split here in ogres, and I'm going to create a factory here. Okay, and this is kind of where I can see the package visibility attribute being useful here. So again, here is sort of our structure here. Now, the first thing I'm going to do here is sort of set this up here. And again, if you didn't see my previous videos on just generically, or how to set up a package or how imports work, I'd recommend you check those and kind of watch these videos in sequence. But again, here's a refresher. So modules, this is within the ogres folder in factory, right? So again, we have this structure of, using the directory and then what this file name is. So that's one here. This module is ogres.ogre. Okay. And again, if you're not used to my text editor, the name of the file's at the bottom here. So that's just what I'm matching. And again, with the factory, you see this factory here. And again, for this module here, now this is the package. So it's just going to be ogres here. And then I'm going to do a public import for this particular one that just brings in everything here. So it's going to bring in ogres.ogre. And it's going to bring in ogres.factory. And the order doesn't really matter here. Okay. So again, now that I've saved those files, we can look at our tree here, and you can again see the structure here. So I've got my main.d file and my ogre package, which just has everything, meaning it's going to include this thing and this module as well. Okay. So let's go ahead and just test this out, make sure it's working. Let's import ogres, and let's go ahead and see if it works here. Now, if I just compile it with this will be a good quiz. Think about if this works or not. And let's go ahead and hit compile. It compiles, but I am going to run into an actual problem here once I start using something in there. Okay, so let's revisit this idea here. Let's just do a little bit more work here. Let's create our ogre struct. And I don't know, let's give it a strength of some sort. I'm going to need a few things here. Let's give ourselves IO because it'll be useful to debug later. And let's go back to our main here. Let's try to create our ogre O. And let's see what happens here if I try to compile this. Okay, so far so good. Looks like I've brought in my module. Let's add a little bit more power here. Let's say I do some action. And I'm going to write line, raw, my strength is, and you could do whatever you want here, but that'll be the idea here. Let's compile that here, and let's actually do our action. All right, let's see if we get any output here. Oh, we don't. Okay, so this is what I was worried about. Because a struct is just data, so we didn't really get any error there. But, once we start doing something, we start getting these, well, not syntax errors, but linker errors here. And if you actually take a moment to read them, right, they're not too scary, saying undefined reference to this action. And you'll say, hey, I do have it in my code here, but, I'm not referencing it. So the D language is, again, helping us here, and it's saying, hey, just use -i, and that'll basically bring in all the imports here that it finds, right, to try to resolve this linker error. So you can fix this in two ways. You use -i and then main.d, and it'll compile, right? We can see raw, my strength is whatever. Or I can, compile these and find the files in, my hierarchy. Let's see, I think I need ogre at the least here, and that'll also work here, which is a little bit messier. So maybe I'll just use this -i trick. Okay, but that's doing the same thing as just bringing in all the imports that we find here. Again, all of those imports are found where? Well, in my package, which is down here, which is effectively just bringing in everything. Okay, so that's the idea. And again, the really, really nice thing is that just importing, exactly, your package here, then I just have one place where I can set up all those imports for the things that I want publicly accessible. So anyways, that's the idea here. Now that we have this set up here, let's actually start using or getting ready to set up our visibility attribute here. And the way that I've sort of separated this out here, again, let's clean this up here, is, I've got my main file, and then I've got some object or maybe family of objects that I want to create. Ogre is sort of the main thing, and then I have maybe some pattern or maybe some family of functions that assist, right? Maybe this is like the factory, maybe it's like an output file or something that pretty prints ogres, but these are just sort of like free functions, right? And that's the basic idea here that I thought maybe this package attribute could be useful for helping me split up my files. Again, maybe it's easier to just put everything in one file here, right? And you'd list out your struct and a bunch of free functions below it. But sometimes you want to separate things out, or if you're trying to, again, use some pattern where you want users to be able to extend this struct through some, other known file or exposed file, again, that might be a way to do it here, okay? So anyways, with that idea here, let's do a little factory here. I'm just gonna call this make ogre, And it's just going to be a little simple function that we create an ogre O. We're going to allocate it on the heap. Let's return it. So something like that. Let's make sure it compiles here. Let's see. And let's see. Undefined identifier in my factory. Okay, so I still gotta import the right stuff within my module here. So again, let's play around with that here. I could just bring in ogres, or I could just bring in the one I just need this struct here. So again, I'll try to do the responsible thing here. That works. Okay, so we have a factory function here. And then let's go ahead and use this here. Okay, so now we're returning a pointer here from our factory, make ogre. We could do our action. Let's see, compiles and runs. Okay, so great. This is a nice way to separate out our code potentially. Okay, I've got again. Let's show you the structure. My type, and then maybe free functions here, like a factory, or maybe some other pattern here, okay? Because maybe I have 30 different ways to make certain different objects, and I can separate these out in a separate pattern here. Now, here's where things get interesting though, and we could finally get to the package attribute here, is if I'm trying to be a good programmer and say, well, I don't want to expose strength here, okay? Because maybe I want to make these ogres here. And let's use an example here. Let's add a few more lines of code here. Let's make strong ogre. Okay, and o.strength is going to equal 100. Okay, something of that nature here. Okay, so again, just so you can see the whole file, there it is. So again, let's see if this compiles. I gotta spell things right. That's always the first challenge. There we go, strength. I use my autocomplete. Well, wait a second here. I auto-completed it. Okay, so it was spelled right and says no property strength for O of type ogre. Well, of course not, right? I've made it private, so it's just encapsulated here, okay? So, I can't access this, strength thing. And then that means, I can't, let's go ahead and make ogre 2 here. And this was what? Make strong ogre. There we go. And do O2 action. Okay, can't do that yet because we're getting our compilation errors. But again, this has to deal with the visibility here. Private means private to just this module. So just this file that I'm highlighting. So if I want to make this visible, well, I could do something like public. And I should be able to compile this and run it. Okay, so it is working. It's giving us our 2 ogres. Let's just show that here. Making our ogre, our default one, and doing an action, make our stronger ogre and doing the action here. You can see the strength has changed. No problem there. But now I've exposed my code to everybody though, okay? And this is just a struct, so I don't have protected or something else for it. So I need some other visibility level for this. So that's gonna be package here, okay? So let's go ahead and try this. And basically what I wanna see here is that this code still works here, but that strength isn't, totally available. Okay, so let's go ahead and do, again, a few more rounds of experiments here. So this works. This works perfectly. My package here of ogres consists of the ogre, that's this guy here, and the factory, that's this guy here. So every, one of those files, strength is visible here. But what if I go here and I say, haha, I want to use O2 strength equals, 10,000 now. Go ahead and compile it. No property available, okay? Because, again, I've encapsulated it within my package, okay? If I want it totally available, right, you can make things public, and that's sort of like no rules, just symbols are visible, but I probably want to encapsulate data members at the least within a file or potentially a package if I find it's helpful to split things up here. Okay, so hopefully that makes sense. I think it's a really cool thing. It's a sort of missing granularity, of other languages. But if you have this sort of package system and this ability to sort of collect modules together, it sort of makes sense to have this. So other languages have this. Again, D has this, which is really, really nice. And I found it's a nice way to, where it makes sense, encourage splitting up your files. If you want to look at your file as having separate responsibilities, like it's probably easy to read a code base that has a file called factory with all the ways to make some sort of object, or all the aliases to templated functions to make up, objects if you have that sort of code base. Again, it can just be a really, really helpful tool without letting your data sort of leak all over the place. Okay, so anyways, that's the idea here. Hopefully you enjoyed that lesson, folks. That is on the package attribute. And again, we got a good review of all the other visibility attributes, the import system, and packages again. So hopefully that makes sense if that's new for you. It was new for me when I came from C++ to the D programming language. So, I thought it was worth spending some time to explain. So anyways, if you enjoyed that, check out course.mshot.io. You can find out all the D language, videos that you're watching here, also there if you want to track your progress. So anyways, folks, thanks for your time and attention. I hope you enjoyed that video. Let me know if you've used the package attribute, if you think it's a good thing, useful, if it's helped you build libraries and these sorts of things. And with that said, otherwise, folks, I'll look forward to seeing you in the next one.